Hi, welcome to Teardown Tuesday. We've seen this one before. This was sent into the mailbag segment recently by Chris Bowden from the Geek Group. So I'll link in the Geek Group down below. Thank you very much, Chris. He went to a lot of expense and effort to send this to us, and what it is it's an analog computer for an inertial navigation system, an Astro compass system used on the B52 Bomber. So let's check it out. Awesome. And it's manufactured by Kollsman Instrument Corporation in the US, and it says it's the MD1, but there's an MD3 label on it, so maybe it was upgraded, you know, retrofitted at a later point, and it comes from an Air Force base in Utah. That's where they presumably maintain and service these things. I believe this one might have was retired in the 80s because, ta-da, let's have a look. There you go. This is the apparently the decommissioning stamp or whatever. 20th of November 1985. I think that's when they would have last checked it or whatever. But yeah, it's I don't think they use these suckers anymore in the B52s, which are still flying. These airframes are like 50 years old. Absolutely crazy. Anyway, let's check it out. Now, this is part of a much bigger system for the inertial navigation system with the Astro compass, which would be on top of the plane, which actually has optical sights, little telescopes that actually sight stars and things like that. And that's how you used to navigate before GPS. With the and before that, they used to use sextants and things like that. You know, the old school pilots probably still whack out their sextant occasionally and go, yeah, we're about here. You know, she'll be right. But yeah, this is a small part of it. We believe it's some sort of analog computer or something like that. So it's basically in a full pressurized type container. And after the mailbag, a viewer who knows about these things said that this is manufactured. There's some screws on here we can take out from the front, but it's actually held in here with tape. And the tape is with welded tape or something. So maybe we should be able to cut around that. Hopefully I don't have to grind the thing open because, well, yeah, can't do that here in the lab. That's going to be nasty, and it's already getting a bit messy. Actually, I believe he said it was like soldered on with metal tape or something. You know, some sort of process like that. So yeah, I don't know. I might do. Maybe we can, once we get the screws off, maybe we can just whack it with a hammer and, I don't know, see if it cracks the joint or something like that. And I don't really know what this nut on the front does. I assume it's some sort of pressure port. Can't feel anything. So, yeah. Oh, okay. Yep, it's a valve. There you go. You can fill it up. Tiny little bit of air came out. That's it. So I don't know. Would they have pressurized it with some sort of gas or something? But anyway, yep. That looks like a standard bike valve almost. Actually, I've got an interesting story about that. When I was working in underwater sonar stuff, I had to go to the local bike shop and buy 100 bike inner tubes so we could actually cut the valve on these things, and then we drilled a hole in a metal plug similar size to this in our our plastic plug in our product, and then we epoxied it on the inside so that we could actually fill these things up and do it for refill them for test purposes and things like that. So yeah, you know, try walking in a local bike store. I'd like to buy 100 inner tubes, please. Well, the hammer thing didn't work. Wah, 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 wah. All right, time to get medieval on its ass. You can really start to see the solder joint around this thing crack. Very interesting. I presume it's some sort of soldering method. I don't know what this metal is either. It's quite lightweight for its, you know, its size and everything else. So it's not steel. It's some sort of, I don't know. Anyone out there got a clue? Some sort of alloy thing. I don't know. And there it is. She's coming apart. Look at that. So smooth inner surface. You can really see where they've sort of soldered that thing shut. So it's like cracking right around the top here. So this isn't a bad way to go. I hope it doesn't damage anything inside, but not functional anymore really. But you know, probably better than grinding the thing open, I think. And I think she's about to pop. Maybe a few more whacks and... And we're in like Flynn. Wow. Check it out. It's a bit sharp. Wow, look at that. Beauty. And if you want to see what's inside the can, well, nothing much. It's just an empty can. There you go. I knew it! The B52 was just a cover. It's from a downed UFO. Wow, check it out. This really is engineering porn at its finest. We have ourselves a genuine mechanical analog computer. Now, I wasn't actually sure what one it would actually be. I was hoping it'd be a mechanical analog computer like this, because analog computers are basically come in two different types. You've got analog ones like this, which actually use gears and cogs and everything else to actually do the calculations. And that's effectively what it's doing. It is actually doing mathematical calculations. And the other type is an electronic analog computer, where it uses op amps. Basically, that's what op amps were originally developed for. Op amp stands for operational amplifier, hence the name operational. It performs mathematical operations, addition, subtraction, multiplication, etc. You can actually do using op amps. So I wasn't actually quite sure which one it would be, but we've got ourselves a mechanical analog computer. So you won't actually find well, hardly any. I can see a resistor in there. I can see a couple of resistors, but you basically will not find electronics, or, you know, hardly any of it inside here at all. It is all gears, cogs, and everything else. Isn't it just gorgeous? Absolutely gorgeous. Oh. Now, at first, you might think that this part here is a gyroscope. It looks quite gyroscopic, if that's the correct term. You would think that this thing, you know, spins around here and all that sort of stuff on its own axis, but it doesn't. Like, I can't physically get in there and move that, but if I turn some of the cogs, of course, you might be able to see that spinning. I'm actually spinning a little bar on the top here, and I'll show you this more up close later, but basically I can make this. You can see this slowly moving around like this. So this part swings around like that. There's another one in here which then spins this like that. And there's got to be another one which actually spins this whole rocks, this whole top mechanism, this whole top bar is not fixed. It's actually, it's on a bearing there and connected up to the top here to these cogs. So it's all, you know, it all spins around in there like that, but it's not a gyroscope, like as in actually, you know, it holds a reference frame for a moving object. All this stuff in here is designed to actually compute something using the cogs. I believe this is how it works, by the way. I am certainly no expert on mechanical analog computers and things like that, but all these cogs down in here are going to do all the computational stuff. Now, I'll do my best to show you all of the parts of this thing, but it's going to be incredibly difficult, and I don't want to take it all apart. A, because there's, you know, not much point in it. You're not going to be able to, you know, there's no real huge value. And B, somebody might know how I can power this thing up and possibly make it do something. So you can see this threaded rod here. As I turn that spins around, and then that spins, whoa! Something just released down the bottom. I'll show you that in a second. But then this basically spins this large outer cog here. Here we go. There you go. And then that in turn turns other ones down in the base. You can actually see down there, that one down there, which is spinning, that one's actually got a... It almost looks like it's got a band on it. And what I mean by that is, we'll have a look at this one down here. Look at these two. Here we go. This thing is something that just sprung back. Look, it's got like a... Look, it's got... Ah, there we go. Look, it's got a band on there. You can see it actually come out. Look at that. So the exact purpose of that, I've got no idea whatsoever. If anyone's really into mechanical analog computers, I'm sure they're screaming at me. And you can actually see, yes, we have a little bit of circuitry down in there. Look at that. Or do we have some sort of solenoid type thing? Perhaps? I don't know, but sort of, that's kind of like the extent of the electronics inside this thing. It's basically, it is one big mechanical computer. So we're basically going to have motors and sensors in this thing. Motors are the inputs, of course, so you can think of those as, the inputs to this control system, this analog computer, are driving the motors, and then the motors drive the gears and the cogs, which do all the computation based on how many teeth they got and the configuration of them and everything else. And then the outputs will come from sensors, hopefully we can, rotational sensors and all that sort of stuff, which you can find. Now here's a motor. I'm not sure if you're going to be able to read that, but this is a Kollsman motor. Dublin? Is it made in Dublin? I don't know. Anyway, it looks like they actually, not only do they manufacture this whole thing, they manufacture the motors that go in them as well. Awesome. And yes, in case you're wondering, it does have that vintage military electronic smell. And then we've got things like this, it says it's a synchro control transformer, I believe. So that's obviously taking, it's going to have a cog on the other side. So, obviously maybe it's got its own cogs inside that's doing something else, things like that. There we go, Coleman Motor Corporation, Dublin. It's a motor, tachometer, ta-da, generator. So what that does is basically output a voltage that is proportional to its shaft speed in there, basically. So it can get the rotational speed of the rest of, or whatever is hooked up to the cogs, way deep down in the system. Down in there somewhere. Why it needs that, I don't know. Could be like a rate of change input or something like that. Perhaps? Anyway, there's several of those spread around here in various places. So I think there's 2 or 3 of those. And you can see these synchronous control transformers here. You can see that they are actually attached to a cog on this side, which then goes into this one. I can't turn these manually. And then they go into, here and go into the base of the system. Base of the, I don't know what you'd call that. Anyway, you can see it down in there. There we go. All the cogs are right down in there. And then that's also wired into that spring belt mechanism there that does something. I don't know. Does it take up tension or something which may actually have some sort of mathematical function to it? Because that's effectively what we're doing here. We're translating mechanical spring and cog and everything else motion into basically to simulate formulas, doing calculations, hence why it's an mechanical analog computer. It is actually doing math. And you can see right down on the base plate of this whole thing which turns at the bottom, you can see there's various other cogs and things down there, and then they also go into the transformers down here as well. And there are various limit switches in this thing. You can see this cog here has 3 micro switches on it with these little plastic bits which rotate around and then turn on this micro switch. Look at that. So I don't know, why they got the 3 levels as it rotates. Once again, it's doing some sort of maybe limit function or, limit switch. That's, typically it could be doing something like that. And we've got some limit switches on this entire mechanism on the top, which also, it doesn't rotate around completely. It's only got a limited travel path from here to here, but it's basically got some limit switches on there which will stop that. And, I don't know, are we, out of lock or something like that? That's as far as it can actually compute, and it can't, do anything more. I don't know. Your plane's upside down and doing something stupid, and it's just chucking a wobbly. And there's yet more limit switches around here. There we go. Once again, look, micro switches. We've got 4 of them there. with various wheels, and that all comes from God knows where inside there. It's just crazy trying to understand this thing. Anyway, don't you just love all the lumen in here? It's all tied in, everything, individual wires are branched off, all the lumen parts. I love these little tag, little crimps, and they're actually tied, individually screwed down on there. Are they joiners, or, you know, maybe they'd be very convenient test points. And look at this. Ta-da! You might recognise D25s. What the hell? We got D25s. Well, they are a military-style connector, a military version, but it's basically a D25. Each wire is individually heat shrunk, no worries whatsoever. Just the cable tie bundles in there are just, look at them. Wow. What a gigantic... what is it, a lead screw, worm screw, whatever you call them, I don't know. Sorry, I'm no mechanical engineering expert in there. And that is on this arm, which does eventually probably, you know, you probably have to rotate the other parts 1,000 times or something to have this thing swing over. And you can see the big cog there that this thing is going to swing on. So, but I can't force it to actually do anything there at the moment. So all I can do is just, you know, turn these screws here and play around with that internal mechanism. You can see that spin along there. There you go. See that spin? That'll go all the way with LBJ. Actually, is it my imagination, or is this moving as well? I don't know. Oh, it's spinning back now. I'm getting a bit of resistance. That's probably not a good thing. It's probably not good to spin this by hand, by the way, but you can see how it travels. It can travel all the way along that arc, and it can come all the way out this other side as well. Oh, sorry. It's a bit dark in there. I don't think you can adequately see it, but I can't see it on the screen anyway. And everything, you can see the cogs all turning down the bottom as well. The complexity of this mechanism is just absolutely incredible. We're getting towards the limit here. At the moment, we'll hit some sort of limit in a second. Don't know what's going to happen. I probably shouldn't go too far, should I? No, don't like that. Yeah, so all of this, while it does look sort of gyroscopic, probably shouldn't pick it up by that, but it's a convenient handle. It's so robust. It's just incredible. You know, I was smashing this thing apart with a hammer, and it's just, you know, no damage whatsoever. It's built like a brick dunny, really is. But yeah, so, you know, if you powered this thing up, you know, it's not like it's going to stabilize and then you know, move this. It doesn't this does not compensate for movement, okay? It's purely a mechanical analog computer that almost certainly doesn't care for its orientation at all. You know, there'll be gyroscopes elsewhere in the plane feeding all the data into here. There's the telescopic sight mechanism, as I said, on top of the plane, which gets the azimuth data, of course, which is the angle from north of where the star is that you're actually trying to track, and things like that. So ultimately, I believe what this section here is the trigonometry math part of it, because this thing, you know, it's got these guides in here which go around what goes around in a motion, you know, maybe comes back in a motion like that. Well, sinusoidal function, right? So I expect this thing to move forward and then back and have some sort of, you know, trigonometry type function, because you ultimately need to calculate your azimuth and your altitude as well, and that requires basic trigonometry, all the stuff you learn in school, you know, calculate, you know, the opposite over the hypotenuse, all that sort of stuff. To get the angle in there, you need sinusoidal functions in there, and I reckon that's what this inner part is doing. Mathematical sinusoidal operations. Brilliant. Woo, man, it's just gorgeous, isn't it? Look at it. Thing of beauty. Joy forever. Now, it might actually be orientation sensitive as such, I'm not sure, but anyway, I've had it in different orientations, and sometimes it allows me to manually rotate things, and other times it doesn't. But anyway, well, it shouldn't be. that is my educated guess, is that it should not be orientation sensitive. It should work in any orientation. But anyway, I don't know, maybe it's gummy after all these years. Anyway, what I'm going to do now is I'm going to do a bit of a time lapse here and just spin this, and you'll see, as you know, as far as I can, and you'll probably see this thing turn, but you'll see it sort of like turn back on itself. It'll go one direction, then automatically go the other, even though I'm not changing direction of the way I'm spinning this particular arm in here, okay? So here we go. So hopefully you just saw like this arm move down and then back up like that. It didn't like go all the way around. You know, this is not a general purpose computer. It is, you know, designed for a specific, to calculate a specific thing, i.e., you know, all your stuff required for flight and navigation and stuff like that. So it'd have very specific calculations, you know, pre-programmed, all the cogs, all the mechanism behind that. And I think it's just absolutely fascinating. See, now if I turn it on its side like that, I really am having a hard time actually doing that. But if I just put it up like, oh, I think I heard that tension spring go again. So maybe that's got something to do with it. But now, no drama whatsoever. I'll get a deeper shot inside there, see if I can show you. And while I was doing that, I saw this cog on the back actually spin one way and then back the other as well. I'll see if I can do that again. Okay, so it's spinning counterclockwise. And then there it goes, it's going back. This is brilliant. Jeez, I can play with this all day long. Great stuff. Now, there's an interesting little black part down in here. It says Allied Control something. I can't make it out. Minus 65 degrees C. What the? Anyway, 26.5 volts, control 5 amps, whatever that is. But it's, yeah, it's interesting. It's got, you can see the wiring coming out of it there. So is there some electronics in there? I don't know. Is there an op amp in there? Is it doing a combination of mechanical and electronic analog computing? Perhaps. I don't think so, but you know, maybe it's got something to do with, you know, the limit mechanisms. It's got patent pending written on the back of it, and it says blue bead with an arrow, bead. B-E-A-D. So I don't know what that means, with an arrow pointing to like the pins on the bottom or something. Really quite unusual what that thing's doing. I'm just amazed at all the complexity of the cogs and everything in this. It's just absolutely amazing how they can design this thing. But I don't know, people have been designing analog computers since, you know, a couple of hundred BC. And as I've shown, we've got both this inner shaft here with this worm screw on it, which connects through to that cog there, and we've got this one on the other side, and this one over here turns the inner part and then also turns that wheel down there. This one turns the whole lot like that around. So I can actually spin both of those at once. I have no idea what I'm doing. I'm probably crashing my B52 Bomber. But, well, yeah, I think we hit some sort of limit there. But the interesting thing to note is that both this shaft here can cause this inner part to rotate, to actually move along this part part here, and this one can make it do the same as well. You can see it moving inside there. Okay, move it back. But this one can also make that part move, or it can. I was getting it to move. Trust me. So they're like, it's almost like, two inputs, two variable inputs to the system, perhaps. There we go. It is actually slowly rotating around there. So yeah, two inputs which are, being multiplied together or something. There's some math operation happening there. I get no idea what though. But I still have not been able to get this part to rock back and forth like that on, on its arm. So as I said, maybe that's, if you spin the thing, 10,000 times, maybe it will move that back and forth. But yeah, I don't know at this stage. Oh, it's just ridiculous. Yeah, and I've heard these little spring things. Oh no, I need to put that back. Oh, tragic. Oh, I shouldn't be dicking with this. Anyway, I think that's enough of me dicking around with this thing, pretending that I know anything about mechanical analog computers. So if anyone can shed more light into this, even perhaps how to maybe power it up and at least, make it spin or do, something under power control, that'd be terrific. As I said, I don't see any value in taking the thing apart any further. You just get a bunch of cogs and everything else. It's like, it's too good to take apart. So, it's worth keeping just as a fantastic ornament piece, if anything. Otherwise, it'd be nice to maybe be able to, drive it and just make it go spin and do something all day. I don't know. Anyway, that is inside the Coleman Industries MD1/MD3 Astro Compass, automatic Astro Compass / analog computer from a B52 Bomber to do its flight computing and things like that. Basically, it's a star tracker. I'd love to get the optical telescope and everything that hooks up to this sort of thing, which sticks out the top of the plane and sights the stars. And my hat's off to the people who designed not just this, not just the mechanism, the cogs and everything else, and figured out how it all works, but the entire star tracking system, flight guidance computer, all mechanical. Like doing what a pilot did with a sextant back in the day. When they had to fly with sextants. But no, basically it's an electronic sextant. It tracks the stars and lets you know where you are and guides the plane. I don't know if it flies. It's not like the autopilot or anything like that. It just does the computations for the azimuth and other stuff. In fact, it might only do the azimuth. Maybe there's another part of the system which does and computes something else. But anyway, if you do have any info on how this thing works, then I'd love to do a follow-up video actually explaining more as it comes to hand, because I have not researched this thing at all. This is just off-the-cuff teardown. But anyway, yeah, if you've got any knowledge of this sucker, please leave it in the comments. Anyway, I hope you enjoyed that teardown. If you did, please give it a big thumbs up, discuss it on the forum, everything else down there. And thanks to all my Patreon supporters, and that's linked down below. As always, EEVblog newsletter, all linked down below. Subscribe to my channel, all that sort of jazz. Catch you next time.